Okay, Engine Principles Test 14. This is a basic knowledge test. And everybody's got somebody's test besides theirs?
I got my own test.
No, swap tests with somebody. You don't need to grade your own test. Let somebody else grade your test. Let somebody else grade your test. Okay. Which of the four strokes is pictured in that picture number 1? Which of the four strokes is pictured here?
You gotta call out on somebody.
Huh?
No, you gotta just call the answer.
No, you gotta call out on somebody.
All right. Okay, Zach. Which of the four strokes is pictured in that number 1?
Intake.
Okay. And how do you know this?
I don't know this. I guess.
Second rate amateur. How do you know? How do you know it's the intake, guys?
What about last year? Told you.
You see the fuel layer next year.
Yeah. Which way is the piston moving?
Down.
Piston moving down. All right. Which way is the air moving that's coming in? Yes. You look at the arrows. The air's coming in. The air's coming in. The piston's moving down. So that's going to be the intake stroke, right? Notice which way the crankshaft is turning. Got me? All right. That's good. Now then, on that next question, which one of those is an overhead cam engine? Which? Huh? One on the left. That's right. You know the cam is on it. All right. Number 3. As related to
Pointed
the.
the arrow left and wrote right.
Just give it to him.
Pardon me?
Like,
arrow for a reason.
You drew the
Huh?
arrow towards the left engine. Look at this.
You got the proper
YouTube, that's what he did.
Let's see where he did. Where?
He put left, but wrote right.
Who did that?
Maybe he meant the left one.
Brilliant.
The right
Okay.
one. The left one's the right
Outstanding
one.
performance. That's your other right. Okay. Okay. Well, he pointed an arrow at the right one, you know. So that's all right. Don't let him.
I say we get it.
Nobody knows. Okay, come on. As related to oil, the word viscosity refers to what?
Zach put 5W30. I have no idea.
Huh?
Viscosity? What I got for viscosity?
I mean, I don't know, like, it's
Sure, it's
the thickness of the hole.
What does the word viscosity mean? It's something. Huh?
Thickness.
Yeah, thickness is a good answer. I mean, you know.
It's not contaminated.
Well, no, viscosity has got to do with how it flows, or the thickness of it. Like, for instance, if you got something like, if I'm pouring vinegar, it's going to pour like water. If I'm pouring syrup, it's going to pour thick. And syrup is more viscous.
Okay.
You see what? That's what that's talking about. It's not talking about the purity of it. It's talking basically the way it pours. Okay, and finally, number 4, a 5W30 designation means what?
With the weight.
I mean, W stands for winter, but I didn't know.
W stands for winter. That's easy for you to remember, isn't it?
Yeah. I remember that verse since the first day he told
Yeah.
me.
That's right. Matt Winters is going to remember that winter is like, so we can call him Matt Waite. What?
So what are you saying?
I'm saying that the oil, that the oil varies from 5 when it's cold to 30 when it's hot.
That's what that means?
Yeah. That means it acts like a 5 oil. Let's just use the word weight. It acts like a 5 weight oil when it's cold. Why do you want it to act like a lower weight oil when it's cold? If you're out there where it's cold in the cold wintertime and your starter is having to spin that crankshaft and it's churning through this thick syrup in the crankcase, it's loading the electrical system a lot and all. So you want your oil to be easy for the crankshaft to churn it when it's cold, churn through it. So you want it to act like thin oil, but when it's hot, it's going to lubricate better if it's thick. So you got a multi-viscosity oil that acts like a 30 weight oil when it's hot, but acts like a 5 weight oil when it's cold. See? And that's basically why you're using a multi-viscosity oil like that. Because you're basically wanting the best of both worlds, and the engineers have learned how to do that. Now then, number 5. Janie says she has to add a quart of oil to her vehicle every week. Name the 2 places the oil might be going. Well, no, just these are simple answers. We're not asking for specifics. Into the combustion chamber or out on the ground.
Okay.
You know?
I was thinking of like where it could be coming out at.
Yeah. Well, the 2. Well, that's a subjective question, but basically, it's either going to be burning it or it's going to be leaking it. That's the 2. You could say burning or leaking it. Now some of y'all were probably thinking valve cover gasket, intake gasket, and all that. But what else is the possibility? If it's using the oil, like if the oil rings are clogged up with crud and they're not wiping the oil off as they come down, they can burn the oil. You send somebody to take off and make it smoke over. Okay, we've got a conversation going at table number 3 over there that's not sanctioned. Okay, engine cooling system has 2 primary jobs. What are they?
Cooling system to keep the cooling.
Circulating
Power
coolant.
heating and the heater.
To keep the engine from running too cold and to keep it from running too hot.
Circulating coolant.
Yeah. Well, no, coolant is part of the cooling system.
And it's part of the heater system too.
Yeah. Well, yeah, as far as the engine goes, you know, as far as the HVAC goes, yeah, this could keep you warm whenever you turn the heater on. But anyway, if you didn't put it, keeps it from running too cold and running too hot, then you crashed and burned on that question. Okay. And let me say, 100% ethylene glycol will not cool better than a 50-50 mixture with water. Did you know that pure antifreeze, if you pour it into your vehicle, will actually turn it to jelly at about 8 degrees below zero? It'll just turn to jelly and won't flow. And it shall cause you to destroy your motor. You know, if you pour it, if it's really cold. If it gets really, really cold, you'll ruin the engine like that. So you need to mix it, and mix it with that. It's ethylene glycol is formulated active with water, not in place of it. And that answer is obviously going to be what? It's going to be true. Number 8. What purpose does the thermostat serve, and how does it work? What would you tell somebody? Now you got to be able to explain it to a 6-year-old, right? If you can't, you don't explain it yourself.
Open to level water put in.
Actually, it stops the. Go ahead.
I said it maintains like a target temperature range by either bypassing the radiator or letting it flow through.
This is the exact answer I wrote.
That's a good answer. Yeah.
Thermostat stops the circulation of water to the radiator when it does not need to be cooled.
There you go. That's a good answer too.
Spring heats up, it opens up, that water passes through, and it needs to pass through.
Yep. The wax element. What are you talking about over there? All right.
I was explaining it to a 6-year-old.
Yeah, because he needed to know. Okay, I understand why you would have to use that tact with him. Okay, let me see. What system is illustrated below? What system is illustrated below? What is that system? That is the fuel system. We got a fuel tank. We got lines coming up there.
I thought that was a pattern behind the back seat. So that's the IC. What is it?
That's a,
EC. What is it called?
ICE is internal.
no, that's the fuel. Well, look at what you got. You got the filler neck going into the gas tank. You got the lines coming up here to the front. You got the fuel injectors, and so on and so forth. About number 10, what is the colored component indicated by the arrow? What is the colored component? And don't say it's the EGR valve, because if you do, you'll really crash on it.
Intake vacuum.
Huh?
Fuel pressure regulator.
Yay, baby! Fuel pressure regulator. There you go. Okay, number 11. Octane rating simply refers to the volatility of that particular brand of gasoline. It has no relationship to power output. True or false?
False.
True.
You got it wrong.
What's the difference between the high octane gas and the low octane gas? What's the difference? What is it? The properties of it. What did I tell you about higher octane gas? What's the difference between it? What are you getting when you put it in there instead of lower? Like you put 93 instead of 87, what are you getting?
Fires and lower temperature.
Actually, no. It actually burns slower.
What you getting, oil?
It actually burns slower than and an engine that's tuned for 87 octane, if you put 93 in there, it don't all burn. And some of it stays in there, and so it turns into carbon, and you start getting carbon buildup on top of your piston and under your head because it didn't all burn. You know, got surface quenching going on and all kinds of other stuff, but the long and short of it is, if an engine is set up to run on 87 octane, you ain't helping it by putting 93 in it. Because eventually, that carbon will build up, it'll raise the compression to the point to where you can't burn anything but 93 in it, and then it'll get to where it pings when you do that, and you'll start getting a knocking sound because of that carbon. It's going to sound like you got an engine knock, you know. And it basically, it is a sort of an engine knock, but it's because of the carbon in there and not because anything's, you know, loose down in the bottom. Okay, so what are the 3 primary differences between gasoline and diesel engines?
One's spark fired, one's compression fired.
That's a good answer.
Tend to get more torque.
I actually got like 5 differences on my in mine, but you could just get 3 and get by. What about the fact that they use different fuel? That's an easy one. All right.
You only got 2 reasons. One's ignited by compression, the other one's spark.
That's right. That's spark versus compression.
You get half off, right? You only give me 2 reasons.
Huh?
You only give me 2 reasons, not 3.
Well, what about how about the way the fuel is delivered? The fuel is basically, on the ones that they make nowadays, is delivered right into the combustion chamber on that one. Of course, on your gasoline direct injection engine is too. They're equipped with glow plugs in each cylinder that heats the combustion chamber during cold starts. They don't have throttle plates to regulate the air. Now, occasionally you'll run into a diesel engine, like an electronic diesel, that's got a throttle plate so that it can facilitate EGR flow, but that's not for the same reason that a gasoline engine. They don't have vacuum. A diesel engine doesn't have vacuum. It is pulling air in, but there's no vacuum because there's no throttle plate. All right, number 13. What's the purpose of the distributor in an engine that has a distributor?
To spin on top of the engine and fire it in correct firing order.
Yeah, how about it sorts out the spark and houses the speed or position sensor usually? Usually. Is that a good answer? Okay. Yeah, you guys will know. You guys know if that was answered right or not. You know, let the punishment fit the crime. In a distributorless ignition engine, and I'm talking about with coil packs, not with coil on plug. How often does a spark plug fire during a 4-stroke cycle of a single cylinder? Twice. Every time that piston comes up, it fires. If it's got a coil pack. Every time that thing comes up, it fires. What are you laughing about? What's the matter? Somebody crashed on that? Ah, all right. Yeah. Well, we talk more about that when we get into engine performance. Okay.
I remember you saying something about it. Fires the first time just for ignition or whatever. And then
The second time it fires just because it fires. It don't fire for no reason in the second time. It's like a motorcycle. It doesn't hurt a dadgum thing, and it doesn't change anything for it to fire in the exhaust stroke. It just fires during the exhaust stroke because it don't hurt for it to fire there. It ain't got nothing to do in there, and most of the sparks don't go toward the cylinder that's operating anyway. All right, the measure of how much the air. We're going to move on to this next test now. This next knowledge test, and so hang on to that. The one you got, and grade that one too. The measure of how much the air fuel mixture is compressed during a compression stroke is the what?
combustion chamber ratio.
What?
I don't know. Hey.
Compression ratio. That's the compression ratio. Somebody took a wild guess at that one, and y'all should know more than that. The cylinders, the pistons, and the crankshaft are all located where?
The combustion chamber.
In the engine block.
Did you really put that? No.
If there's an answer that can be wrong, he's going to pick it. All right. Number 3, the air filter and throttle body are parts of what?
Air induction.
Air induction system. That's a good answer. 4, the primary heat transfer device for the engine is the what?
Radiator.
This is not tough, is it? If the thermostat stick closed, what will happen?
Engine will overheat.
Okay.
Sticks open, it won't overheat.
Okay, now see, they also got this thing about higher exhaust emissions. If I was telling you that an engine was running just a little hotter than it was supposed to, and this is something we learn about next semester in emissions, what emission would increase as a result of the engine running slightly too hot? If it starts to run too hot, one of the exhaust emissions goes up. You know which one it is? Remember that, because next semester I'm going to ask you that again. Okay, one of the exhaust emissions, and you're primarily dealing with 3 of them, is going to go up higher when the engine's running hotter. And somebody might know that next semester that don't know it now. All right, now then. Okay. Let me see. To test the thermostat, what are you supposed to use? Huh? A pressure tester?
I have no idea, I guess.
A refractometer? What does a refractometer do? Who's used one in here? A lot of you guys have used it. You know that thing you look through that I got? That's the refractometer. You going to test the thermostat with that? I don't think so. All right, we've eliminated 2. Coolant hydrometer is whenever you squeeze that bulb and it pulls some antifreeze up in there. How many balls there are that floats or whatever is going to tell you what the specific weight of the coolant is. Okay, so it's got to be a scan tool. Now, how am I going to test the thermostat with a scan tool?
You're gonna watch the
Watch the coolant temperature. We've done it out here, guys. Watch the coolant temperature, and you're going to see it heat up, and then it's going to go back down, then it's go up again, it's going to go down, it's going to go up again. Every time it goes down and up, you know, the thermostat. You know, the fan kicks on and runs it down some too, but the thermostat, when the thermostat opens, you're going to see it drop.
I checked it with that computer screen.
That works. That's exactly right. The same deal. That's a computer's a scan tool. I mean, it's just wireless. Okay, let me see here. The internal passages for coolant in the engine block and cylinder head critical for proper engine cooling are called what? Water jackets, you guys. Water jackets. Water jackets.
I don't know, water jackets, I don't know what that is.
The water jacket is the place where the coolant flows around the cylinders and through the head. You know, in that little animation that I got out there of that engine running, you know, if you see the piston going up and down, you can see the places around it where the water flows and everything. You can also see that when we pull an engine apart out there, you can see where the water jackets are. The blank test evaluates individual cylinder performance by disabling one cylinder at a time and noting RPM drop. That's number 8. Cylinder power balance. You remember the worksheet I gave you?
That was a compression test, too.
No, the compression test is not going to tell you that. As far as it's not going to evaluate individual cylinder performance. Back in the day, and I've got a video I put on YouTube about that. You know, you're going to kill the spark plugs wires one at a time, and the one that doesn't make any difference is the one that's skipping.
Right.
Or you can disconnect injectors and do that too.
Right. That's what I'm saying. What was that?
That's a cylinder power balance test. We're going to see which cylinder's putting out power. Yeah, cylinder power balance.
When I did that, we pulled a number 4 and it didn't.
Yeah, exactly. That's exactly what I'm talking about. You pull the spark plug wire, and on that worksheet you was doing, you pull a plug wire and it didn't change anything. And when you pull it, put it back, pull it, put it back, and it's doing the same thing. I mean, it's still missing, yeah. Okay, a written or electronic record of the vehicle is known as a what?
Service history.
Yeah, that's going to be a service history. And one of the NATEF tasks we're doing here is you guys are supposed to know how to research the service history on the vehicle. That is a little bit easier if you're in a place where there's a lot of service histories kept. But you can go on the manufacturer's website, put the serial number in, and in some cases pull a service history like that as far as what was done under warranty. But the way that they keep these things, like in your dealerships and stuff, is they'll have a file folder that usually uses the last 6 digits of the vehicle identification number. And, you know, they'll have a girl up there usually in a huge bunch of bank of file cabinets, and they'll actually have them all filed. So
They've been doing that a long time ago. It's on computers now.
that's a good idea. But the long and the short of it is, we were able to go over there, and it's smart to do it that way. I mean, who needs all them file cabinets and stuff? But we had a guy that came one time back to when I was working over at the Ford place, and he says, I had my car worked over here a year ago, and the engine, you know, it quit, and the guy had put an ignition module on it, and he said whoever worked on it last broke the ignition module. Well, that's the one that was on the side of the distributor, and people have a tendency to pry on those when they're trying to set the time, and they'll bust them, you know. And so I got called up front, and he says, and the guy that was running the place was a real straight-up guy. Not the service manager, but the guy that was running the place. And the service manager was trying to tap dance around and get out of it, and the guy up front, the man that ran the place, wanted to know what the truth was. That's all he wanted to know. I want to know what the truth is. You know, because this was a $100 repair, if this guy had to do this because of something we did. So I says, okay, let me check. So I went back there and pulled the service history on the vehicle. I went to the file folder with this serial number, and I pulled it out. And the last time we worked on it had been just under a year ago, and we had pulled the intake manifold off and put it back on. And the guy that had worked on it was a sort of not all that good at some things. And so I knew he had to pull the distributor out and put it back, and I also knew he went to set the time, and I also knew he pried on that thing probably, because that was the way that guy typically did stuff. And of course he wasn't there anymore, you know. But I went back and I told the big boss man, I said, we did it. And so we took him to the cashier's office and made him give him his money back for the repair. You know, and he had it repaired somewhere else. But the long and short of it was, that's what I like working for a guy. He wasn't trying to get out of giving the guy his money back. He was trying to find out what the truth was. See what I mean? That's the kind of people you want to work for. Somebody that all they're interested in is what's true. And all they're interested in is in doing what's right. I saw him give money back to people that I never would have given it back to if I'd have been in charge. You know what I mean? I mean, see, he was just always want to make sure everybody was happy and there was nobody upset, you know, and that kind of thing. But anyway, of course, if somebody complains too much, you know, after a while they become persona non grata. You get on out of here with your bad self and everything, you know. All right, so, all right, where are we at here? Let's see. An uneven reading on the cranking vacuum test may indicate what? An uneven reading on the cranking vacuum test.
B.
Like an erratic upslope on the secondary firing line can be floating valves. Everybody knew that, though, right? But let's look at here. Which one you got? Number 10? Number B. There's an air leak in one or more cylinders if you got an uneven reading on a crank and vacuum test. Crank and vacuum. How much crank and vacuum you usually going to have when you're spinning one over? Remember that? If you know, vacuum, when it's running, it's going to be 18 to 20 inches or 18 to 22 or something. If it's cranking, you're going to have 2 or 3 or 4 inches of vacuum, all that much. But if you see it, you know, doing things uneven, bouncing, that's what they're talking about. Number 11, too much clearance between the rocker arm and the valve stem causes what?
Valve train noises.
That's going to be valve train noises when they clickety 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 click. All right, the cleaning process used for small parts such as valve springs, spring retainers, and valve keepers is,
Obvious.
that's going to be thermal.
Thermal.
Yeah. Hot. Okay, number 13. Of course, you can dip it in some carburetor soap, but that's expensive. 13. What kind of cleaning is used to clean pistons, valves, and connecting rods?
Brake.
What you got? That's going to be B. Shot. You ever seen one of these big old cabinets that's got a window in it and gloves built into it, and you know, it's got a little sort of a shot, almost like a sandblaster, but they use a shot to clean it. Number 14. The following components must be reinstalled in their original position.
D.
Which ones?
All of them.
The pistons and connecting rods. It's not a bad idea to put the push rods back where they came from, but you don't have to. Temperature or pressure sensors, that sounds like a good one there. Push rods, rocker arms, and all that. What do you think? All of the above might be a good answer for that, because you don't want to put your temperature and pressure sensors in a different place. You don't want to do that, do you? And if you're really a stickler, and I will tell you this, and in all the engine work I've done, I don't typically put the push rods back in the same place. Some people do, and it's probably a good idea to do that. But most of the guys that I know just clean the push rods up and put them over there in a nice, neat little row, and the rocker arms, they lay them out and all that kind of stuff, but they may put them back anywhere, you know. But if you want to be a real stickler for accuracy, it's a good idea to put them right back where they came from. But it won't make, I've never known of a problem happening because somebody didn't put the push rods and the rocker arms back, as long as all the push rods are the same length. And when your little V6 engines, some of them will be short and some of them will be long on these, like these 3.1 and these Pontiac and all that. You'll have a long one and a short one, like 5.5 and 6 inch. You got to put those back where they go, or you're going to have some serious issues. So pay attention to the length of them. Number 13. Let me see. Excuse me. I've done that one. Excuse me. Number 15. Remove the valve train components before removing the cylinder head on what kind of an engine? Number 15. That's going to be D. All of the above. All right. Number 16, a metric micrometer reads in millimeters. The marks below the revolution line are in increments of A, 5 millimeters, B, half a millimeter, which would be 0.5, C, 0.05 millimeters, or D, 0.01 inch. What's that right? That's going to be B. That's 5/100ths of a millimeter. Pressure testing, dye penetrant inspection, and magnetic particle inspection are several ways to check for what?
Correct.
That's the cracks in the cylinder head. That's a good answer there. There you go. Number 17. Wow. Number 18. The engine block must be inspected for all of the following except what?
D.
C.
That's what now?
Flywheel flange, power flange.
Now, is that going to be? Is that the engine block?
Except.
Yeah. Except you're not going to check the engine block for flywheel flange and pilot hole. That's part of the crankshaft, right? That's going to be C. You got it? All right, you got that? All right, now then, measure an instrument used to measure cylinder bore, crankshaft main bores, and a large end of a connecting rod is what?
Dowel.
You can use a dowel bore gauge, and that's good. I got one of those in there, by the way. Which?
That's what I saw it on the writing on the kit.
Yeah. An automotive machinist should perform which of the following tasks? Repairing a cylinder head crack, restoring flatness if a cylinder head is warped, or valve guide replacement. All of the above. My dad used to do valve jobs on them Volkswagens, and he had just brass valve guides, and he would drill a hole. I mean, he would put threads in the valve guide, and he would screw a bolt in there and then drive them out of the head with a punch. And he would take his other valve guides and have them in the freezer. He kept all his valve guides in the freezer because they'd be colder and it'd be easier to put in there, you know. See a lot of people say, some of those diesel engines where the wrist pins that go into pistons, you put the pistons in really, really, really hot water. And then when you pull them out of the hot water, you can just slide that thing, that wrist pin in there with your finger and then put your, clips in it. But you can't do it on an automotive piston. You got to have a special, machine shop. Got to press it on there. Number 21, valve stem height is the distance between what?
Valves,
One end of the valve guide and the other end?
that's what I said.
21.
All of those say that at the same time.
Valve stem height. The valve stem tip in the valve guide?
What's the answer?
What do you think? What does it sound like? Valve stem height.
D.
What's the answer?
I want somebody to tell me.
I said eight.
I said D.
One end of the valve guide.
The seat to the tip.
Yeah. How many different answers do we have in here?
4.
Yeah. We got 4 different. I mean, how many answers do we have in the room?
Probably like 2.
Yeah, about 2 different answers. What do you think?
Said D.
Is it the valve spring seat and the valve guide? Think about that, what you're looking at. The valve stem tip in the valve guide? That's probably what I'd pick right there. Why not? 21. If it's wrong, it's wrong. Look at it and tell me. Aluminum cylinder heads always use valve guides made of what? Number 22. Steel valve guides. They use steel valve guides. Now the aluminum cylinder, that's not a good answer, and I'm going to tell you why. Those Volkswagens that my dad worked on for so many years in Bugs, they had brass valve guides, and they were aluminum cylinder heads. So why did it say always? See, always is a bad way to word a question. Why don't they say usually? Okay, number 23, valve seat surfaces are machined to the correct angles and width using what? Number 23. A valve machining tool. We got one of those over here, and I give you a worksheet next semester in engine repair too, where you actually grind valves, with that machine. That valve grinding machine is a really exact machine, that rocks just so. And one day I handed this guy a piece of steel when we were building that Toyota stand where that engine is over, and he walked over there. I pointed over in the general direction of where the grinder was, and I said, go over there around the corner off on this plate so it won't be so sharp. And so I went back to what I was doing, and when I looked up, I heard him grinding, and he had it on the valve grinding machine, using my valve grinding, which is, a really exactly surfaced rock, and he was grinding it, using it for a bench grinder. I was just shocked, just horrified, what are you doing? I had to replace that rock because he ruined it. Okay, number 24, valve with 2 little, what's valve margin? What's the margin on a valve?
Let me draw it.
You want to draw the margin?
I don't know what's.
See if you can draw it.
Right.
You got to draw it where the camera can see it, right here. That's good. Now draw me the margin.
All right. That's like flat, okay?
That's a great picture.
You're pretty good. He's a pretty good artist. He can draw. All right, now show me the margin.
All right. Now the margin.
Okay. Matt, this is embarrassing. The margin, you got to...
It's on video.
Now watch that. This is a valve right here,
That's close.
and that right there is the margin.
That's what he meant to put.
Yeah, that's what I meant.
Yeah, that's what you meant. But anyway, this is where it's ground to seat, and the margin is that little flat place. I got it drawn really thick to
Demonstrate.
to demonstrate, but it's that little place. And I got a valve here. See this one here? See that valve right there? See that little flat place around the edge? You don't want that valve, you don't want it coming all the way to the edge, because if you come all the way to the edge, you'll have hot spots around there, it'll burn the valve. So you need a margin there. Now that valve there is obviously bent. You turn it around, you can see it. But anyway, the margin is that little flat place on the edge, the thickness that's between the part where it's ground and the top. That's the margin. Okay. And so, okay, somebody, give Matt a double X on his paper. Okay, let me see. Number 25. Where's 25? Did I got a 25 or did I have a 25?
There ain't no 25.
Well, that's 24.
Okay. Well, you're right. I stopped on 24. All right.
What was the answer number 24?
My answer number 24.
All those two.
What do you think?
All of the
24?
above.
Let me look at the question again and make sure that answer key's right. 24. Too little margin, it may overheat, fail, cause pre-ignition, all of the above. How can it fail? It's going to burn. Pre-ignition, how does it cause pre-ignition? if anything in that combustion chamber gets hot and stays hot, like little glowing coals of carbon or the edge of the valve or something